Welcome to Career Guidance Max playlist. So in this video I'm going to start maxima and minima for the functions of two variable. So from this section you will get 1 8 mark definitely. If you want to attend 1 8 mark from this section means you should know these two conditions. The stationary point. I'm not going to explain what is stationary point, just you can understand. If we want to find stationary point, we have to equate fx equal to 0 and fy is equal to 0 is nothing but partial differentiation function f with respect to x, and this fy is representing partial differentiation with respect to y. Already you know how to apply partial differential equation. What is the condition we need to apply for partial differential equation? The very simple, when you are partially differentiating with respect to x, keeping y as a constant. When you are differentiating with respect to y, keeping x as a constant. Okay, that is the main concept we are going to apply while doing problem under partial differential equation. Okay, then after stationary point you should know what is sufficient condition, that is f double x. F double x is nothing but second derivative dou square f divided by dou x square. Okay, we have to equate into a. F double x is what? A. And b, dou square f divided by dou x into dou y. So this is also second derivative. Fxy is represent in the form of dou square f divided by dou x into dou y. This is called A and this is called B. And C, f double y, second derivative dou square f divided by dou y square, which is called C. If you know fx, fy, and this 2 is represent first derivative, this 3 is represent second derivative. If you know this first derivative, second derivative means we can do problem easily. The procedure, we have to find a maximum and minimum value for two variables. In last unit also we seen maximum minima, but here we have taken two variable. Okay, so the procedure is very simple one. After finding first derivative, second derivative, I'm going to apply the procedure. When we want to find the maximum value, your condition should be like this: ac minus b square greater than 0, whether maximum or minimum. This should be satisfied always. ac minus b square greater than 0. Then only we can able to conclude whether it is maximum or minimum. Always we should satisfy this condition. And here additionally a less than 0. When this condition satisfied, ac minus b square greater than 0 and a less than 0 means it is maximum. This condition satisfied greater than 0, but a value greater than 0 means it is minimum. These two you should remember always. A less than 0 means maximum, a greater than 0 means minimum. ac minus b square greater than 0 is always satisfied. Otherwise we cannot able to find maximum and minimum value. And third one is here given the function is not extremum. Extremum is nothing but whether it is not a maximum, not a minimum. That is called extremum, not a extremum. Extremum is maximum, minimum. Okay, it is not a extremum. ac minus b square less than 0 means which is called a saddle point. Okay, so when you are drawing a curve you will get like this. This is called saddle point. Okay, and ac minus b square equal to 0 means it is inconclusive. We cannot able to conclude whether it is maximum or minimum. There is no value. Okay, so if you want to attend the problem, first you should understand stationary point and the sufficient condition. Stationary point is nothing but first derivative we have to equate into 0, and sufficient condition f double x we have to consider a, fxy we have to consider b, f double y we have to consider c. And procedure, after finding a, b, c, we can able to write ac minus b square. When I am writing ac minus b square, if I get greater than 0 means which is our we can able to find maximum, minimum. Based on this a less than 0 means maximum, a greater than 0 means minimum. So based on this stationary point, we can able to, based on this stationary point, we can able to conclude whether it is a maximum point or minimum point. Okay, so now I'm going to solve one problem from this section. The first one is the problem number 1. So see, problem number 1 is find the extreme values of the function f of x comma y is equal to x cube plus y cube plus minus 3x minus 12y plus 20. Right? So I'll write the function of x comma y is equal to x cube plus y cube minus 3x minus 12y plus 20. Okay, so this is our equation, given equation. So this equation I'm going to differentiate partially with respect to x, that means fx. Okay, so this is equation 1. Equation 1 I'm going to partially differentiate with respect to x cube differentiation 3x square. Here y cube differentiation, there is no x term, it is 0, and minus 3 constant x differentiation 1, and here there is no x term, so it is 0, and it is a constant, there is no x, it is 0. Right? Now I'll write fx is equal to 3x square minus 3. So this is our fx, first derivative. Okay, again equation 1 I'm going to partially differentiate with respect to y. Fy is equal to, here x cube, there is no y term, so it is constant 0, plus y cube differentiation 3y square, and minus 3x, there is no y term 0, the y differentiation minus 12, okay, into y is 1 and 20 0. So simplify this, fy equal to 3y square minus 12. Okay, so this is our equation 3. Now we know fx and fy. Next I am going to find f double x. This fx term, equation 2, I am going to partially differentiate with respect to x again. So I will get 3 into x square differentiation 2x, 3 into 2x, it is constant, so 0. So from this I will get f double x equal to 6x. Okay, then I will find fxy. This is our f double x. Next I am going to find fxy. So from equation 2, this fx term I am going to partially differentiate with respect to y. Is there any y term in this equation 2? There is no y term. We cannot able to differentiate this term. Simply we can put 0, which is equation number 4, and this one equation number 5. Right? Then I am going to find f double y equal to, how to find f double y? Already we know equation 3 fy. This fy term again you can partially differentiate with respect to y. I'll get 3 into y square differentiation 2y, and this one minus 12 constant 0. Simplify this, I'll get f double y is equal to 6y. Okay, so this is equation number 6. So first initially we identified first derivative and second derivative. Now I am going to find stationary point. A very simple manner how to find stationary point. Already you know that how to find stationary point. So we have to take first one fx equal to 0, and second condition fy equal to 0. So we have to equate. Right? So here your fx and fy, see in your problem fx and fy, fx equal to 3x square minus 3, fy is 3y square minus 12. This fx equal to 0 means we have to equate this 3x square minus 3 equal to 0. This 3x square minus 3 equal to 0. So from this you can take 3 common outside. I will get x square minus 1 equal to 0. 3 shift to right hand side, it is 0. Already x square minus 1 equal to 0. So I will get x square equal to plus 1. That means the value x equal to plus or minus 1. Okay, wow. The value x equal to plus or minus 1. If you want to find stationary point, you should know what is y point. So here fy equal to 0 I am going to apply. Here fy equal to 0 means 3y square minus 12 equating to 0. 3y square minus 12 equating to 0. So from this equation I will take outside 3. That means I will get y square. I take 3 outside. Here you may get 4 equal to 0. 3 shift to right hand side, it is 0. Y square minus 4 equal to 0. And y square equal to plus 4, y equal to plus or minus 2. Right? Here, now we know the values of x and y. Based on this x, y, I will write the stationary point. The stationary points are, in x you can take plus 1 and club with y values. So plus 1 plus 2 and next plus 1 minus 2. Okay, wow. Next you can take x minus 1 value and combine with y value, plus 2 and minus 2. That's it. So is this our stationary point? Now we know stationary point. Based on this stationary point, I am going to conclude. I'm going to find the maximum value and the minimum value. Before that, we should identify A, B, C. Already I given what is A, what is B, what is C. A is f double x, right? That means A equal to 6x. B is fxy, that is here 0. And C is fyy is equal to 6y. So we can take A equal to f double x, that is 6x. B equal to fxy, that is 0. C equal to fyy, that is 6y. Okay, A is f double x, B is fxy, and C is f double y. So based on these three values, I am going to conclude now. So see, here I written stationary point and A, B, C. So based on this A, B, C, I am going to find AC minus B square. Okay, the very simple manner. Next we will find AC minus B square. So next I will conclude based on this AC minus B square and A value. So here I written points and AC minus B square. AC minus B square means A is 6x, C is 6y and B is 0. I substituted here, I will get AC minus B square equal to 36xy. And here A equal to 6x, that is f double x is your A, that is A equal to 6x. Conclusion. Here based on stationary point 1, 2, 1, minus 2, minus 1, 2, minus 1, minus 2. Based on that, I am going to identify maximum and minimum which point gives. Okay. So first, here I will take the point 1, 2. This 1, 2 I am going to substitute here. Consider x equal to 1, y equal to 2. Substitute here. AC minus B square equal to 36 and x equal to 1, y equal to 2. I will get 72, right? So AC minus B square equal to 72 means it is greater than 0. So your condition satisfied. Whenever you are finding maximum value, minimum value, your AC minus B square should be what? Greater than 0. That condition you are satisfied. Next, here I am going to substitute x equal to 1. The first point is x, second point is y. Here I am going to substitute x equal to 1. I will get A equal to 6 of 1. So x. So 6. A equal to 6 means which is also greater than 0. So already AC minus B square greater than 0. A also greater than 0. That means this point gives minimum value. This point 1, 2 gives minimum value. According to a greater than 0 means we can conclude it gives minimum value. When we can conclude this? Only in the case of AC minus B square greater than 0. Otherwise we cannot able to conclude whether it is a minimum or maximum. Okay. Then based on A we can identify minimum or maximum. If it is less than 0, no need to find A. No need. If it is greater than 0 means only we can identify A value. Next point I am going to substitute here AC minus B square equal to 36. Here x equal to 1 and y equal to minus 2. I will get here minus 72. Minus 72 is less than 0. No need to find A because already I told. If it is less than 0, no need to find A. It is saddle point. I given the condition, the procedure itself. Okay. Next I am going to substitute the point minus 1, 2. So AC minus B square equal to 36. X is minus 1. Y is 2. Again I will get minus 72. Which is also less than 0. Okay. So no need to find A. This point also saddle point. Okay, va? Next, AC minus B square equal to 36. X is minus 1. Y is minus 2. Now you will get plus 72 when multiplying this term, which is considered greater than 0 model. AC minus B square is greater than 0 means we can able to find A. Here A equal to 6 into X equal to here minus 1. So that is A equal to minus 6, which is represent less than 0. AC minus B square greater than 0. When it is greater than 0 only we can able to find A. Here A is less than 0. A is less than 0 means maximum value. Maximum value. So that here 1 comma 2 and minus 1 comma 2, minus 1 comma minus 2, these 2 points are gives minimum value and maximum value. Rest of 2 points are saddle point, no need to apply. Okay. So now I am going to find maximum value and minimum value. So first I am going to find maximum value. Maximum value at a point minus 1 comma minus 2. Consider first one x, second one y. So your function given in the question f of x comma y equal to x cube plus y cube minus 3x minus 12y plus 20. Here you can substitute this x and y value. So I will write function of minus 1 comma minus 2. X is minus 1, y is minus 2. Minus 1 whole cube plus minus 2 whole cube minus 3 into x equal to minus 1 minus 12 into y equal to minus 2 plus 20. Okay, simplify this. Minus 1 whole cube minus 1 minus 2 whole cube minus 8 minus 3 into minus 1 plus 3 minus 12 into minus 2 plus 24 and plus 20. Okay, wow. Now you can add all the values 44, 47, 44 and 47 and minus 9. That means you will get the function of minus 1 comma minus 2 is equal to 38. Is this your maximum value at a point minus 1 comma minus 2? In similar way we have to find a minimum value. The very simple, the minimum value at a point 1 comma 2. So I'll write function of x comma y is equal to x cube plus y cube minus 3x minus 12y plus 20. Right off. Here I will substitute 1 and 2. Consider 1 is x, y is 2. Substitute here 1 cube plus 2 cube minus 3 into 1 minus 12 into 2 plus 20. Right? Simplify this 1 plus 8 minus 3 minus 24 plus 20. Okay, and add all the things. Minus 27 plus 20, I will get minus 7. Minus 7 plus 8, I will get plus 1. 1 plus 1, 2. The minimum value when a point 1 comma 2 gives 2. So this is the way we have to find a minimum value and maximum value. Right? The very simple one. So again I will recall what we seen in this video. So first, the very basic thing is the maximum and minimum functions of two variable. You should remember this 2 point. Stationary point f of x, fx equal to 0, fy equating to 0. Then only we can able to find stationary point. Then ABC how to identify based on sufficient condition. A is f double x, B is fxy, C is fwy. That means your function equation I am going to partially differentiate first derivative and second derivative based on this. And the procedure is, whenever you are finding maximum minima, this condition should satisfy. AC minus B square greater than 0 means then you can go for A, otherwise no need. A less than 0 means maximum, A greater than 0 means minimum we can identify. If it is AC minus B square less than 0 means no need to check A, it is a saddle point, no need. And AC minus B square equal to 0 means inconclusive, there is no solution for your problem. Okay, so in this sum, first we identify the derivatives, first derivative and second derivative, fx, fy, and second derivative f double x, fxy and fyy. This f double x we represent A, fxy we represent B, fwy we represent C. Next I identify the stationary point. The very simple one, stationary point fx equating to 0, fy equating to 0. These two equation I am equating to 0, I will get x and y value. Based on x and y we combine the points, we will get the in terms of xy, that is your stationary point. Then ABC, already you know that. I write in the form of table. So points 1 comma 2, 1 comma minus 2, minus 1 comma 2, minus 1 comma minus 2. These points I substituted in the AC minus B square equation. What it is? 36 xy. Consider the point corresponding x equal to y equal to value, substitute. If it is greater than 0 means we can able to find A. A is greater than 0 means minimum value. A is less than 0 means maximum value. If it is AC minus B square less than 0 means no need to find, it is saddle point. Okay, that's it. The very simple one. Any doubt you can comment me, will clarify. Okay, definitely you will get 8 mark from this section. For already we completed Taylor series. In last video, Taylor series problem number 3, I taken function equal to, while substituting the point plus 10, that is not a plus 10, that is minus 10. Just correct it. Okay, thank you pa.